Reading week 2. The main physics idea discussed was basically the electric field of dipole. And dipole is basically 2-point charges that are of opposite signs, and the electric field created by the dipole on the same axis, which means the dipole and the charge that's affected is on the same line, is equal to r hat over 4 pi epsilon 0 times 2 magnitude of p, which is the dipole moment, over r cubed. And the dipole and perpendicular line, where the charge is perpendicular to the p direction of p hat, which is the line from negative charge to positive charge of the dipole, is equal to r hat over 4 pi epsilon 0 times p magnitude of p over r cubed. So the difference between dipole on axis and dipole on perpendicular is that the size of the electric field of dipole on axis is twice as big as dipole on perpendicular. What I already knew was that dipole is equal to 2-point charges that are of opposite signs. And you can induce dipole by placing an external electric field that causes a shift of charges. When you place a negative charge close to a neutral metal, it's going to cause the positive charges to go towards the negative charge and induce an electric field for the metal. What I did not already know was that you can calculate the dipole moment by setting P equal to Q, which is the charge, times S, which is the distance between the negative and positive charge in dipole, and multiply that by the direction, which is from negative to positive charge of the dipole. Something interesting that I learned was that induced dipole is directly related to the external electric field, which means larger the electric field, larger the dipole moment. And how it relates to my major, which is electrical engineering. You can use induced dipole by placing a metal in the electric field and polarizing the metal. And you could also use it to make a neutral object have a dipole moment. I also thought that it could probably be used in switches, so when you place a switch close to a metal that's connecting a circuit, and you could somehow use the dipole moment so that the electric field will make the switch turn on and cause the circuit to be on. A confusing topic for me was the electric field diagram of different dipoles, because I was wondering how a charge placed in the electric field of dipole will be affected due to the charge. And so I searched up the image on the right, which shows the direction of electric field of different types of dipoles. As you can see, for the left top corner, you have the ordinary dipole, and the electric field is pointing out from the positive side and into the negative side. And this is more clearly identified in the diagram next to it, which is labeled charges, and you can see the lines are coming out from the positive charge and going in towards the negative charge. And supplemental resource that I would suggest is the Bozeman Science video of electric field of dipole. Basically, this video tells you how the electric field of a dipole is created, and he shows you how a electric field of the positive charge and electric field of the negative charge can be overlapped, and you can see this nice diagram of how dipole electric field is created. Thank you.